This video, we are going to do a word problem related to slope, right? So we're going to be talking about slope. Bring that up, and we'll talk about that in just a second. So it says sound intensity, I, is measured in watts per square meter. So W is watts per square meter at a point X meters from a sound source with an acoustic power P, right? So your volume kind of thing. It is given by this equation, right? So your intensity at a certain point away from it is our power divided by 4 pi x squared. A typical sound system of a rock concert produces an acoustic power of about the power equaling 3 watts. So compute the slope of the intensity at 3 meters from the sound and interpret the result. All right, so that's what we got. So there's our slope. We're finding a slope at a particular point, which means this is our equation that we're going to be using. All right, because remember, slope at a point is the limit as h approaches 0, f of it, a plus h minus f of a equaling h. So let's start with the fact that p equals 3, right? So that's going to be replaced with 3 over 4 pi x squared. So our intensity is going to be 3 over 4 pi x squared. But I'm going to write it one other little way just to kind of help our cause of what we're about to do. So I'm going to pull the 3 over 4 pi off, and I'm going to make it times 1 over x squared. Because this is the equation that we need to focus on, not so much this. All right, and I'll show you how we can take advantage of that. So here we are. We're going to be doing the intensity at 3. All right, so we're going to be applying this formula. Right, so we're going to be doing the limit as h approaches 0, and we are going to be doing I of 3 plus h, right? Our function is I. Okay, so it's this. And then here's our a value plus, so 3 plus h minus the intensity at 3 divided by h. All right, so we're going to have some algebra that we're going to have to fight through. So let's start plugging things in. So our limit as h approaches 0. We're going to take and plug this in. We're going to have this 3/4, 3 over 4 pi kind of floating in front. And then we're going to have a 1 over 3 plus h squared. All right, and then minus this one, which is, again, 3 over 4 pi times 1 over 3 squared. Okay, so I'm just taking this and plugging it into here, taking this and plugging it into here, divided by h. All right, so let's start to simplify this stuff here a little bit. We got a limit as h approaches 0. I'm going to pull this 3 over 4 pi off of both of these two, just to hopefully make our math a little bit nicer. We have 1 over 3 plus h squared, and then minus 1/9 over h. All right, so here's what I can do at this point. Any constant that kind of is sitting in front, there's some properties of limits. I can take that out and just kind of eventually multiply it back in. So I can do the limit of this. So I'm going to do 3 over 4 pi times the limit as h approaches 0 of this inside. Okay, so what I'm going to do is I'm going to try to also kind of multitask this a little bit. I need a common denominator between these two, so then I can multiply by the reciprocal, and there's some math that I need to do, but I need to make a common denominator first. So this one needs a 9. This one is going to need the 3 plus h squared. So I'm going to have a 9 over 9 multiplying to the 1 over 3 plus h squared, and then minus the 1 over 9. I'm going to need a 3 plus h squared multiplied top and bottom. all of that over h. Right, so if I put all this together, I'm gonna have a 9 on the top, so I'm still gonna have this 3 over 4 pi. The limit h approaches 0. I'm gonna have a 9 minus this 3 plus h squared over our common denominator of 9 times 3 plus h squared all over h. All right, so at this point, that's pretty much the best that I can do on there. So what I need to do is I'm going to multiply by the reciprocal, right? So I'm going to be taking this. I'm not going to mess with the denominator here. So let me write this down over 4 pi, right? And I have still the limit. H approaches 0. And then instead, I'm going to have, instead of dividing by h, I'm going to multiply by its reciprocal. All right, which also tells me that I'm going to need some sort of just an h to cancel out. So I'm going to need an h that I can factor to cancel out that problem, because that's my 0 being plugged in. So what I need to do is go ahead and distribute this and then take 9 minus and combine our like terms. The denominator I'm not messing with. Let's say h squared. So it's going to be a 9 minus, and then if I multiply that out, I'd have a 3 times a 3. And then I'd have a 3h and another 3h, so 6h plus h squared. Right? So let's combine our like terms. Still haven't plugged in 0 yet, but we're very close. So we would have a 9 minus 9 minus 6h minus h squared over 9. Not messing with this denominator. And 1 over h. So if I put some stuff together, what I should have left are nothing, pieces that have h's. So these two go away. That's a great sign. Okay, so let's go back to it. So we have a 3 over 4 pi, limit h approaches 0. We have a negative 6h minus h squared over the 9, 3 plus h squared times 1 over h. And I have an h that I can factor out of those that I can cancel with this, and then we're ready to plug in. Because right now, if we plug in 0, we'd have a 0 over 0, which that means the limit exists. We just have to adjust. So limit as h approaches 0, we factor an h out, we'd have a negative 6 minus h over 9 times 3 plus h squared times 1 over h. There's our h's canceling. Finally, we are now left with 3 over 4 pi. Limit h goes to 0. We're left with a negative 6 minus h over 9 times 3 plus h squared. All right, plug in our 0. So we're looking at negative 6 minus 0 divided by 9 times 3 plus 0 squared. All right, so 3 over 4 pi. We have a negative 6, and that's going to be 3 squared is 9 times the 9 is 81. And then I can put these fractions finally together, talk about what our answer is. So we have that 3 is going to simplify with that 81, making it a 27. That's a 1. We're going to take a 2 out of both of those, so that'll be a 2. That'll be a 3. So we're getting a negative 3 over, oh, wait, then I can simplify that, 3 with that 27. Even better. And so that's giving us a -1 over 18. Don't forget your pi. All right, so that is our answer. What the heck does that mean? So if you go back real quick, we'll just summarize that we were looking for what's the intensity was this equation, right? If we have this rock concert going on and we have our power at 3 watts. So we have this intensity. We're trying to find the intensity at 3 meters from the sound source, and it's a -18. The fact that it's negative is a good thing because what we have is the further out we go, the intensity is decreasing. So that is a negative slope, so a negative rate of change. So our sound, so the sound intensity is decreasing at a rate of 1 over 18 pi watts per meter squared at a point 3 meters from source. Right, and it's probably not constant. Further out you go, it probably dissipates quicker. And we would figure that out by plugging in a different value. Maybe what is it at 4? Right, so we could do this math and plug in and see what it would be at 4. But that is our answer for that problem.